So welcome everybody to a new chapter of the Epic Virtual Company Tour series, where we have the opportunity to discover the facilities of our members and also to know more about their activities. My name is Antonio Castelo. I am Technology Manager at Epic, the European Photonics Industry Consortium. And today I have the pleasure to introduce you the French company SEDI-ATI and all the staffs that as they will guide us during the tour in the facilities. SEDI-ATI is a company located in Évry-Courcouronnes in southern Paris, and they are focusing the development of fiber optical components and solutions for customized applications and also for complex or extreme environments. Today, you will have the chance to make your questions, so do not hesitate to raise your hand and ask directly during the tour. I will be moderating the questions. And now it's time to know more about their activities. So I would like to introduce you to Jean-François Vincent. He's the CEO of SEDI-ATI Fibres Optics. So Jean-François, nice to meet you.
So, welcome to SEDI-ATI Fibres Optiques. We are a French manufacturer of fiber optic-based component and solution. Our mission is to bring light for our customer to their complex and extreme environment. Here we have 40 people working here. In 2021, we had a turnover of 6.4 million euro with an annual growth rate of more than 5% since I bought the company in 2016. And we target to hit 10 million euro in 5 years. So now we will move upstairs.
So, Jean-François, you mentioned about the complex and extreme environments, but what does exactly mean for you?
So, extreme environment mean, for example, extreme temperature from cryogenic to a temperature higher than 1000 degrees Celsius. This means also extreme pressure for ultra vacuum to hyperbar condition. And this means also a very high level of radiation in front of the reactor of a nuclear plant. So here I will go to the open space. So here you have my office, and here the open space for the sales and marketing forces. So I present to you Claire Guyonnet. She's our sales and marketing director, and I leave you with her.
Thank you. Hello. Welcome to SEDI-ATI. So you have here the technical sales team. We work closely with our customer to custom design the best suitable solutions to solve their issue. In fact, each customer project is a new challenge. We address demanding markets such as military and aerospace. We have also some research it could be astronomical project or quantum computing. We have industry. We have also energy, geophysical application, nuclear application, and so on, and medical application where we can have invasive probes for medical treatment, but also component that will be implemented in instrumentation for diagnostic systems.
Do you basically cover, Claire, the French market, or do you also have international activities with other countries?
Yes, we do have export. We have almost 40% of our turnover, which is made abroad. And we intend in the 5 coming years to reach about 50%. By the way, we just opened a new office 1 year ago in Amsterdam to address the Nordics. And then I think I should introduce you Hervé Aubé. He's our business line manager. He's dealing with a major project within the company that needs to be dealt with the R&D department. So I will join him for the continuing the tour, and I wish you a very nice talk.
Hi, So my role is to work closely with the sales department and the R&D team, and to determine the feasibility of the request of the customer regarding the strategy which is defined by the direction. So let's go for a tour.
And Hervé, I have a question during this work, because Claire told us about in the industry, about medical, also about energy, that are quite demanding markets. And how do you manage the quality standards, certifications, and these other kind of documents you need for these kind of activities in these specific markets?
For the different applications, we are, of course, ISO 9001, and we have also the quality certification for 13,485, which is for the medical. And we have also a CE marking for sterilized medical device that we can provide to our customer.
Okay, thank you.
At this floor, we have all the administrative function with the marketing, the sales team, the accounting department, and the direction, and the R&D. And downstairs, we have the production floor. We have built this building in 2010. Regarding the aspect that we want all the manufacturing at the first floor and the administrative at the second floor. Over there, I can show you the workshop. On this workshop, we have the raw material that we use, which is, of course, the fiber. So we manage about more than 100 different numbers of fibers. And we have also a large number of tubing to make the jacketing. The jacketing is chosen following the application of the customer, of course. And we have the large choice of fiber to determine the right fiber for the right application. Over there, we have two respooling machines, which allow us to deliver sub-lengths of spool for the workshops or directly to the customer.
And do you also buy not only the fiber but also coated fibers? So do you have coating capabilities in your facilities?
In fact, both. We have fiber with metal jacketing and metal coating, but we have also the possibility to work on metallized pigtails, where we could put a metallic layer directly on the fiber, and so the fiber could be brazed directly on the components.
Okay.
Over there, we have a laboratory for polarization maintaining fiber. You can see there some mounting directly on this kind of fiber, and it consists to align the polarization of the fiber, the two stress rod, which is the slow axis, regarding the axis of the ferrule or the connector. On this laboratory, we work on a large number of components. Over there, we have a control room, which allows us, of course, to check and to control all the mechanical parts that we receive from our subcontractor. And we have also in this room a bench tool with an accuracy of about 2 microns, which allow us to measure with a right level of quality all the mechanic parts that we receive from our manufacturer. Over there, you can see right now a 3-day system that is useful for us to work on a prototype or to work on tools for the method activity. Thank you. Here we have a very long bench which allows us to put the fiber in a special jacketing. The length of this bench is 40 meters. So we can put the fiber in a special jacketing It could be a PU, a PE, a PFA, a PVC, a stainless steel. And it's very convenient for us to choose the right fiber, to choose the right jacket for the environments of the request or the specification of the customer, and to adjust the prototype on this bench.
And Hervé, as you mentioned different kind of materials, do you also have different techniques for this jacketing process, or do you use the same procedure with all the materials?
No, of course, we can push or pull the fiber in the jacketing, and sometimes we use both in the same time. It could be push and pull. But every kind of work is defined following the number of channels that we use, the type of the fiber. Of course, it's completely different if I have a small fiber like a single mode compared to a large core multi-mode fiber, which is a 1000 micron core.
While Hervé is working, I just want to remember that you can make your questions, so feel free to raise your hand to make your questions to Hervé. Thank you, Hervé. You can continue. Sorry.
Okay, no problem. Over there, we have an aging and drying room where we have a climatic chamber that we use for stabilize most of our product. When we work on a space application, for example, of all the products which are polymer need to be stabilized. It's the same for the gluing or epoxy that we could use. So very often we use this product in the process and on the stabilized process.
And I have a question also about the aging. Do you use also to reject some of the products in case they fail in the test, or is just a standard procedure to confirm the quality?
Yes, all our products, we test a large number of our products. For example, the hermetic fit-through, 100% of the hermetic fit-through are under test and deliver with a PV test.
Okay, thank you.
Also, we make a large number of different measurements following the wavelengths that we have on the product or on the specification. Of course, it's very difficult to have all the wavelengths available on different bench of metrology, but we have a large number of it. On this workshop, which is the main workshop, we have several operators, and we try to have a large level of polyvalence and possibility to have several operators for one part of the process to be sure that we are not blocked by the lack of one operator, for example. Over there, for example, we make the connectorization. We can go in this workshop. On this connectorization part, we make the polishing of ferrules, the polishing of connectors. We have several types of connectors, of course. It could be standard or it could be a custom one. We have also this order of manufacturing that we use. It's very useful for us because all of the operators have a badge and they can scan the badge and scan the order manufacturing on these tools. So we can follow the time that we have previous for the process or for the manufacturing, and to follow at the end of the work of the operator to follow what is the real time. So we can adjust. Firstly, to be sure that the right time is on the specification, but also to be sure that all the operators that we have have the good level for the training and have all the information to make the right product. If there is something wrong, of course, we can detect it very easily with this system.
And Hervé, you mentioned that you provide also customized connectors. Is this the normal case, or do you also have a standard connector for most of the requests you receive from the customers?
In fact, we have both. We work on a large number of standard connectors that we are polished together on this kind of tool, which is very useful and convenient for all of the manufacturers on optical fiber. But also we develop some specific connectors like FCX or like NanoX when those connectors are not available on the market. So for space application or for military and air flight application, we can develop some specific connectors. Those connectors could be sealed, which is very convenient and very useful, but we have also some possibility to make the connector with a brazing or with a glass soldering.
Understood, thank you.
Over there, you can see a room which is a specific one, and the access is restricted because we make a specific spool for unmanned vehicle, and the vehicles are guided by the optical fiber, and we have also to move the vehicle, but also to have the video back on the fiber. So we can make some fibers with 300 meters up to several tens of kilometers. And those fibers are for land application, submarine application, and aerial drones.
We cannot go inside, right, of the room?
No, we cannot go inside because all of these products and most of them are under non-disclosure agreement. So it's a restricted area. Over there, we have a laboratory where we could test hermetic fit-through. All of our hermetic fit-through are 100% test. And we test it with helium leak system, which is very useful for this kind of application. And we have a level of 10⁻⁹ millibar per liter per second for all of our products. Right now, we have an operator which equipped a standard hermetic fit-through with FC APC connectors. There you have a pressure test. Excuse me.
No,
yes.
I was curious about using the helium. Why do you use helium gas for the test?
The helium gas, because it's for safety. Of course, the hydrogen is most with an accuracy which is most important, but it's very dangerous to work with hydrogen. So the near molecule, regarding the size, it's helium, and helium it's absolutely no dangerous for the operator. Mm. That's the reason why. Over there, you have a pressure test up to 1,000 bar, and allow us to make the test on hermetic fit-through for example, geophysical application that we need 1,000 bar regarding 150 degrees C, for example. And at the back of the room, you can see a laminar flow chamber, and it allows us to make some special parts of the process which need to strip the fiber or to strip the coating, even when it's a metal coating or it's a polyimide coating. So we can use a chemical attack like acid, for example, on this chamber. Over there, you have a new workshop, which is a big one with 3 different parts. And each operator have the skin and the level to work in each part of the workshop. There we have what we call the pole for geophysical product. On this pole, we work, for example, on sapphire tip. We make a special conical effect at the end of the sapphire. We make the fit-through. We make a special couplers, which is able to go downhole application. So it means 1,000 bar and 150 degrees. Even in this workshop, like everywhere, you could find again the scan to check the time control. Over there, we have a part of the workshop where we work on a very large quantities of spectrometry applications, which are dedicated for, in this case, for blood analysis. And we work on 1,000 products per month. So it's a very specific for our company. We are able to work on single product and also to work on thousands of products with a high level of accuracy quality.
Rebecca, which range of wavelengths do you use in the spectrophotometers to characterize your products?
For the spectrometers, we could work for 200 nanometers up to 200.2 nanometers, which is the wavelength for the silica product. We have silica following the dopant of hydrogen. We can work with low OH or high OH. So it depends the wavelengths, of course. But we have also some specific material like fluorozirconate or chalcogenide fiber. And we could work on up to 10 microns, for example, with a silver halide fiber.
And do you use FTIR in this case, or is it other kind of a spectrometer?
No, it's FTIR.
FTIR.
Yeah.
Thank you.
On this part of the workshop, we produce and manufacture a large quantity of couplers and multiplexers, which are multi-mode components. And our components are very dedicated for sensors applications, regarding that they are wavelengths independent and they are not dependent of the modal repartition in the fiber, which is very important for the multi-mode application. We have a directivity of the components, which is up to 50 dB. That's the reason why these components are very appreciated for sensors applications. For example, you can see there some arrays of fibers where we could strip the fiber, cut the fibers, clip the fibers, and control it and polish it all together. The technology that we use is polishing and gluing. So over there, you have a polishing step of the process. And after, we can use fiber per fiber to make the right components. On this kind of bench, we can take a fiber per fiber. So we separate the fiber when we are sure of the quality of the fiber, and we can directly mount the components one by one. And you can see over there the kind of, for example, it's like a splicing of the fiber. And we have two fibers just in front of one. So we have a perfect coupler, which is mounting directly by a UV cure system. All the steps of the components are fixed on this bench, optical parameters. And after, of course, it's only packaging. So we could have a packaging for standard components, which are in a case, or we could have packaging for harsh environments, which are ruggedized with, for example, metal jacket or something like that.
You talked briefly about the gluing process, but which kind of glues do you normally use?
Normally, we use epoxy or UV cure sealing. But very often we could use also a different sort of sealing, like brazing or like glass soldering, which is most useful for our case due to the fact that we work on harsh environments. And for example, for nuclear application, they don't like epoxy. So we are obliged to work on new technologies.
And I guess in the case of glass soldering, the position is quite critical, right? To ensure that the position of both components.
Absolutely, you're right, yes. In this room, we have all the method team that I can show you. Which is alone, but that's not important. Ruslan Beck is working, for example, on this kind of drawings. So we are from the part of view that single drawing is most convenient regarding a long explanation. So all of our products are described by drawings that we could send to the customer and to have the agreement of the customer. And so we are sure of what we are making. And in the same times, Roosnobek is working on the part list that you could see on the order manufacturing, which is the blue paper. All of the part lists are listed inside, and of course, the time that what is previous for the manufacturing also is figured on this part list. Here we have the room for the production director, which is Sylvie. Bonjour. And now let me introduce Sofiane Baba, which is our R&D director, and we will continue the tour with you. Bye-bye.
Before going with Sofiane, I don't know if there is any question from the audience. Again, you can raise your hands and let us know about your question. We don't have questions at this moment, Sofiane, so you can continue, please.
Okay. So now we start our tour. First, we will visit our clean room. So follow me.
Perhaps you can explain a little bit about the protocols for applications in medical market of space market, because I guess they need special requirements. So you can perhaps talk a little bit about that.
Yeah, of course, sure. So here we are in ISO 7 clean room. So in this clean rooms, we manufacture our medical and space product. So first, what you see here in this area, so we produce our medical product about endogenous props for invasive treatment. So for this kind of product, it's a requirement. It's a required specific standards and specific regulations. So, for example, we follow the 13,485 medical standards and the CE marking for serialization. So our operators follow procedures with our internal procedures. They also control the quality of samples for each manufacturing batch, but also I would say, just let me see a little bit. Yeah, so we control the quality, but also we make a tracing for all components which are used for manufacture of these props. And of course, we will we follow steps that are defined by our procedures. So we manufacture 3 kinds of props, and each one has its own procedures. And but the base is the same, because we have to follow all standards, CE standards, and others.
So there are slightly difference in the procedures depending of the application or the product.
Yeah, so I would say there is many procedures, okay, for each prop, but for the steps it's a little bit the same, because it's following and according the CE marking. So let's see the next room. So in this room we produce and we assemble our optical multiplexer for space applications. So with our multiplexer, so we can combine or split 2 spectral ranges. So this technology is unique and specific for SEDI-ATI. And as you can see here, the core of our technology is to deposit liquid coating on the fiber optics. And thanks to this coating, so we can reflect only the selected wavelengths. And of course, as you can guess, in order to reach the cleanest requirements for space systems, so we assemble all these components in this clean rooms. And if we talk about liquid coatings and layers, so SEDI-ATI mastered all process to deposit liquid layers as AR coatings or HR coatings for barg mirrors with a different spectral range. And also we can deposit metallic layers as gold or silver layers along the fiber or at the end face of fibers. And
what's the thickness of these kind of coatings, more or less?
So for you are asking about the materials. So for the materials, you can use only glass materials.
But I'm asking about the thickness. Do you have any range of thickness?
So here for thickness, it's from few nanometers to 2000 nanometers.
Mm-hmm. Okay.
But by layer.
I have another question from Seram Optec, from Andres. Please, Andres. You are muted now.
What is a typical length of fiber on which you can apply metallic coating? So is it meters or is it kilometer or?
No. So we just it's about a few centimeters.
Few centimeters.
So we can say at the end of optical fiber. So just to how to say it's dedicated for two applications. The first one to make biasing if we want to fix our fiber to the connector, and the second application is for SPR spectroscopy.
Mm-hmm. Thank you.
You're welcome.
I think we can continue, Sufyan.
Okay, so now, let me show you something interesting. So the platform. So please follow me. So it all starts from this kind of preform. So the preform is how to say a cylindrical block of pure silica wrapped by lower quality of silica, and then the fiber is drawn from this rod or preform. So then we can make a multitude of variation of fibers depending the materials and the size of core and the claddings. So just to give you one example, so with silica rod or preform of 1 meter length and 10 centimeters of diameters, it allows to obtain single mode fiber of 150 kilometers. So if you want to visit our R&D, so we can go upstairs. We are 6 experts in different fields: optics, optical fibers, optomechanics, and micromechanics. And we develop new products, but the main for us is to develop prototypes or custom made for our customer. So welcome to our R&D labs. So we have 2 rooms. In this room, we assemble our products. We have a second room there to make metrology measurement and optical measurements. And here we have the open space. So all engineers are staying here, and everything starts from, I can say, from this desk with Laurent. So Laurent is mechanical mechanical design. So he designed and drawn all our products. So it could be optical product or sub-assembly, mixing mechanics and fiber optics, and sometimes optics. So when the product is validated on drawings, so then we can go to make a rapid prototype or models. And for that, we dispose the mini machines. As you can see here, we have 3D machine. So to make some mechanical models and small mechanical prototypes. So we dispose of the 3D machining in this room. And of course, we have a 3D printing machine. Prototypes in plastic, as you can see here.
And Sofian, how often do you need to make prototypes for your customers? Is something that you receive often, this kind of request, or this is just in a few cases?
So I can say mainly of our project, or how to say, for our requirements. So we first make prototypes, and then we send them to our customer for validation. After validation, so we can manufacture the final product here or transfer to the production for mass production. So here also we can see the optical fiber fusion welding machine. So we can make several kind of couplers, or we can welding different type of fibers.
Can you weld fibers with different materials, or this is totally impossible?
So we can say it must be same materials. If we make welding 2 or 3 fibers, the materials must be the same. But which kind of materials? Materials must be glass materials.
Okay.
So because we have it's a plasma technology, so we cannot use a plastic or other fragile materials.
Mm-hmm.
So and here we have a precision drilling machine. So it's a very higher precision. So we need them to make some very small holes. Sometimes we can reach a few microns of diameters of the hole. And of course, we have some polishing machines. And in this room, so here we do some or all our optical measurements and qualifications. So we have some lasers for high power tests. And here also we have neodymium laser for welding metal. So if we want to make some brazing between metallic tube and metallic connector, so we can do it with this machine. And of course, for thermal test, so we use this oven. So we put our product inside, connectors, fibers, and we run mini cycle to test them for high temperature.
And which kind of applications do you normally require working in high temperatures?
So for high temperatures, we have some requests from energy, energy market, nuclear market, and industry market. So, of course, we have many imaging systems with different magnification to have good image of our product connectors. Also, we can show you a little bit our product. For example, we manufacture bundles and arrays. So we can manufacture any with any form, with any size, different kinds of fibers. This kind of product is very used for spectroscopy applications and also for sensors. And also, just to show you one example of our cable connectors dedicated for high temperature environment. So this kind of cables can work in high temperature environment. So for several hundred or maybe can go to 1,000 degrees. And also we developed many connectors. For example, F6, our best connector for military and aeronautic applications. So this connector is already qualified mil aero, and it's very low width. So the width of this connector is about 5 grams. And here we have another small connector, which is developed here in our R&D lab. It is NanoX, and NanoX is dedicated for space applications. It is a very low weight. So the weight of these connectors, these two connectors with the connection, the weight is about 3.5 grams.
Sofian, we have another question from Andres from Optiques.
Yeah. When you are talking about 1,000 degrees C, do you mean whole cable can withstand 1,000 degrees C, or is just the edge of a connector can withstand 1,000 degrees C?
So not on the cable, short. It's only a sensor.
Okay. And but I understood you glue this part inside the connector? What kind of, I'm wrong, you just fix it without glue?
So there is no glue for this application for high temperature. We don't use a glue.
Okay.
So we have other technologies, but we cannot talk about it.
Yeah, okay. Thank you.
Welcome.
I'm also curious, Sofian, about this really light component. I don't know if you can tell us a little bit of the materials you use for developing this kind of low weight components.
Yeah, for the material we use the stainless steel material for covers and the packaging. You can say that, and of course there is other materials, but we cannot also talk about it here.
Okay, thank you.
So in this, of course, in this area, we make the assemblies. We assemble our product, our prototype. If it's a new product, after validation, so we transfer it to the production downstairs. And if it's custom made, then we ship it to the customer. And I think here we finished our R&D tour. So thank you for your watching. And
Sofian, before leaving, we have another question from Andres. Yeah. Please, Andres.
Yeah, you show us drone preform, but you didn't show drawing area. I just asking, do you do drawing inside SEDI-ATI, or you just purchase fibers from others?
So our business is focused on the packaging. So we don't manufacture fibers, and so this is positive for us because we have a huge catalog of fiber, and we have a 50 years experience on the fibers, so we can propose all type of fibers.
So you do not manufacture your own fibers.
No.
Okay, I got it. Yeah, so these drone preforms also drawn in other places. Yeah,
of course. Yeah.
Okay.
Yeah, just to give you an idea how come from the fiber.
Thank you.
So you are welcome. So thank you for your watching, and now I will leaving you with Jean-François Blanchot, our CEO. Thank you. Bye-bye.
So hi again, Jean-François. It was really interesting. We saw, I think, a lot of things in your company. How do you proceed in all the steps? I don't know if there is any other question. I give a few seconds. And in the meantime, Jean-François, perhaps you can say a few words just to conclude.
First of all, I want to thank EPIC. I am very glad and very proud of this EPIC virtual company tour. I hope you have enjoyed it. Thank you very much, and see you soon. Bye-bye.
Thank you. And I don't see any other questions. So thank you, Francois. Thank you all the SEDI-ATI team. And also thank you to all the attendees for being here. And I hope you have enjoyed, as we did, the visit to SEDI-ATI facilities. So I think we can close, and feel free to contact us if you have any other question or request afterwards. You have our contact details in the EPIC website. So it was a pleasure, and good afternoon, everybody.
Good afternoon. You're welcome.